to every matric that's watching this video. This video is aiming for the grade level 7 learners. We want to show you what you can expect in an exam paper, what you must know in the work, and how to answer some questions. In this session, we're going to look at responding to the environment and the specific part in humans. If we look at the way that the exam papers is said to be, then we are now busy with this topic. We are busy with responding to the environment, which is 27 marks, 27% of your paper, or 40% of the marks. The parts that it includes here is the brain, the eye, the ear, and the reflex action. So you see it's more or less 40%. So we can more or less make the deduction that there will be 10 marks, but it can be that there's 15, but usually all four of them are represented in an exam paper for 40 marks. Okay, so let's just quickly look what the exam guideline says that we must know. Okay. In Mind the Gap, there's a very nice checklist. We call it the learner's checklist, which at the end you tick to see whether you understand it, and make sure that you can apply the content in there. If we look at what we must know at responding to the environment in humans, it says that we must know the brain, we must know neurons, reflex actions, and the reflex arc. We must know the peripheral system, the autonomic system. Okay. If it's like this indicated in the book, then it means that it's not covered in Mind the Gap, and that is a very good indication to you also that this is for higher level questions. Okay? That higher level questions will come out of this. Because it's a little bit more difficult content. Okay? So make sure that you as level 7 learner work this additional extra. Then brain disorders and injuries. It's also not covered in here. The effect of drugs is not covered here. When we look at the effect of drugs, just make sure the specific drugs is not prescribed. It's just that drugs are prescribed, so make sure that you know that drugs can either be a stimulant or a depressor, and how the two of them then actually work. Then we must know the structure and function of the eye. We must know accommodation. We must know pupillary mechanism. Now, visual defects. Now, usually, visual defects is combined with one of these, or can be separate, but it is here in accommodation, pupillary mechanism. The moment that examiners ask this with a graph or an example, it makes it more difficult, and that is where we will cover the higher cognitive skills in the question papers. Then we know the structure of hearing, structure of the ear. We know hearing and balance. You must be able to differentiate between the two of them. Then the different hearing defects. So that is the parts that we're going to look at the moment. The first part that it says to us that we must know is that we must know the function of the ear. Okay, so this is also from Mind the Gap. So what is important is that you will know the different parts of the ear, that there's an outer ear, an inner ear, and outer ear, middle ear, and inner ear, and what the different parts is in it. Now, if we look at this mind map, it says to us that this is the pinna, and what is the function of the pinna. This is the tympanum. What is the function of the tympanum? What is the ear channel? What is the... So anything on this is level A and B questions. Anything that examiners ask is a totally recall of content. Nee? But if they ask you, nee, why does the pinna, why is why, nee? Again why is the pinna big? Nee? And why does it have its specific shape? Then it becomes a higher cognitive question. Then it's a more difficult question. Then you need to say the form is in such a way that it captures the sound and that it directs the impulse into the ear channel. Okay. Why? What is the structure, nee, of the tympanium? The tympanium is a very thin structure, nee, and it's very stiffly from that side to that side. Nee? Why does it have this structure? Nee? It has this structure because it must act like a drum. When the waves come in here, the sound wave come in here, it will vibrate against that, nee? And these vibrations will be carried over to the 3 ossicles. So you must be able to explain why this structure, nee? Why this structure. The moment you can do that, you will be able to answer the higher cognitive questions. Then it clearly says that we must know hearing, So the best way to learn hearing, and in many question papers, it's a level A question, but you need level A marks. It says you describe the path of a sound wave through the ear. Then you need to say it starts into the pinna catch it, then the tympanium, or it's transmitted inside the ear channel. From the ear channel, it comes to the tympanium. At the tympanium, it creates sound waves. Nee? This sound wave or vibrations is carried through the ossicles. From the ossicles, it goes into the semicircular channels, nee? And from the semicircular channels, it goes into the cochlea. For the cochlea, transfer it to the auditory nerve. So you must be able to describe it in here. You must know specifically what is the difference between the function of the semicircular channels and the one of the cochlea, because it's that will give you your higher marks. Okay, it will give you. So if we look here at the cochlea contains the organ of Corti, the organ of Corti, which converts sound waves into nerve impulses. So the function of the cochlea is hearing related. Okay? While the function of the semicircular channels in the body is to maintain the balance. Okay? To maintain the balance in the body. Because in the 3 semicircular channels and in the succulus and uterus, there are liquid that is thick, and as we move our head, the liquid will flow to a specific direction and it will help us to maintain balance. Balance is one that is often asked as higher cognitive questions, so make sure that you understand that one. Okay? Very nicely summarized in here is also the hearing defect. Okay, is the hearing defect, and what is the 2 hearing defects? And usually they link middle ear infection. They ask the question in the question papers to say what will happen if the Eustachian tube. What will happen if the Eustachian tube is blocked, né? And why is it blocked? It's blocked because of middle ear infection. So it means that there's liquid in the Eustachian tube. It makes that this pressure cannot be maintained, and that makes the ear, gives you ear pain, and that also influences your hearing when you have fluid or something like that. So very important to see if you know it, to see if you can interpret it. Write down the part. So write down the part's name. Write down the function of the part. And lastly, write down the built or the adaptation, or why does the organ look like it looks. And this part is our level C questions. Okay. The next one that they give us to do is the eye. Okay. Now, if we look at the eye, again, it's very important for yourself to know the eye. So the best way to study the eye is specifically to look at the structure of the eye. When we look at the structure of the eye, you will find the empty diagram, or make yourself an empty diagram and then complete it by filling in all the labels, and all the part names of the name of the part as well as its function. Okay, and what is level D and C questions is if you can relate the function with the build. So again, why is this lens? Why is the lens see-through, transparent? Why is it transparent? What is the function of the lens? Why is it transparent? Because it must bend the light rays to make vision possible at the back. So it's very important that we know here. Then a question that is often asked is if the yellow spot is damaged, or a child is born without cones, what is the effect of that? The effect is that he won't be able to see color, and he won't be able to have good night visions. So for level 7 learners, it means you must know exactly what is the functions of the cones and what is the functions of the rods, and how does it influence color vision, and how does it influence night vision. Okay, so if we quickly look at the eye, we see that we have the part here in front, okay, and which is the cornea. Now the cornea is a thin layer that is above the eye, that is responsible for the refraction or bending of the lights. After that, we see there's an opening. Now the opening is a circular opening, and the opening have to do with the entrance of light in the eye. So the moment that you see light, how much light is in the eye, then you know it's the pupil. And that's why you link pupillary mechanism, to the pupil, because it has to do with light, with vision in light and vision in dark. Okay, vision in dark. Then there's aqueous humor. What is the function of the aqueous humor? Why is it there? What is the function of it? The function of it is that it supports the cornea, that it makes sure that the cornea stay in position in the eyeball, so that it does not move. Then we see the lens. Now the lens changes shape, and the moment that we see the lens can become longer or thicker and fatter, we know that this has to do with distance vision. Okay, distance vision. So to understand the eye, you must also be able on your own to describe the path of a light ray, nee? The path of a light stimulus through the eye. Nee? That is usually a question that is asked to test your content knowledge on this one. Now, because the recall of this, the recall of what is the function, what is the part, what's the part, what is the function, is mainly level A and B questions. I want to function on the two parts that lean itself towards the more difficult questions, and that is the pupillary mechanism and the lens, nee? The change of the lens, nee? Which we call accommodation. Now, the best way to know these two processes is again to look at the empty diagram. Now, the moment that you see a diagram where the lenses is different forms, so the moment it influences the lenses, then we know it's accommodation. And accommodation, I always say to the learners, how do I remember accommodation? I remember I need accommodation if I stay far, so far or near. So how do I remember accommodation? It is for far and near vision. Okay, for far and near vision. So if we look at far vision, what happens? We have two types of muscles that play here a role. And this is different from the pupillary mechanism. So it's very important that you have the correct muscles here. The first ones is these muscles, these round muscles, which we call the ciliary muscle. Okay, muscle. And this strings here is the suspensoric ligaments. Okay? And the two of them play a role. So when the ciliary muscles relax, when this muscle relax, it is big. So if it relax, it is big. When it constrict, it is small. Think of a... so if it's relaxed, it is big. And when this muscle is big, when this circulatory muscle is big, then the ligaments are stretched. So the ligaments become tighter, tighter, or we say they are taut. They are taut there. Okay? And when this happens, so the ciliary muscle relaxes, it becomes bigger. As it becomes bigger, these muscles must stretch. As the muscles stretch, the lens become more flat. Flatter, but we don't call it flatter, we call it convex. Okay? We call it convex. So it become convex. Okay? When it become convex, and the light enters here, the light rays are lesser bent. Okay, from there to there, they are lesser bent than when they here. If it come in here, there's a big dent in there, while there's a small dent in there. So it becomes lesser bent, and so it becomes lesser bent here, and it focuses on the retina, and it's sent far. So if we look at far vision, the ciliary muscle is relaxed and the ligaments is constricted. Okay, so CR and LC. When we look at nearby vision, these muscles are relaxed. Oh, so I mixed it now up. Sorry, can I start with this again? I mixed the two around. I'm going to confuse the students. Sorry, Clemens. Okay. Okay, if we look at accommodation, which is the more difficult part and where you can expect your marks to come from, we see that two parts play a role. The lens play a role, and the other part that play a role is the ciliary muscle, the ciliary muscle. So the ciliary muscle must tell you it's in the form of a circle. When the ciliary muscle is relaxed, it's big, and when it's small, it is contracted. So when the ciliary muscles contracts, okay, so when it is relaxed, when it's relaxed, it's small. When it's contract, oh, this is wrong. So when it's relaxed, it's small, and when it's contract, it is big. Okay. So let me explain it like this. If I have a rubber band, when the rubber band is relaxed, it's this size. But when it's contracting, when it contracts, it becomes bigger. Okay? So when the ciliary muscle is big, it means it is contracted. And when it is small, it means it is relaxed. Okay? When it's small, it's relaxed. So a rubber band, if it just lies there, it's small. But as we contract it, it gets bigger. Okay. So if we look for far vision, what happens? The ciliary muscles is relaxed. And because they are relaxed, they are small. They are small, the rubber band is small. And if they are small, it put more tension on the suspensory ligaments, which were then tightened, and as it tightens, less light is bent, or the light is bended less, and it focuses on the retina, and we get vision like that. When we look at nearby vision, then the ciliary muscle, can you see there it's big, so it have contract. So if we think back about the rubber band, it have pulled from this size to this size, so it contract. If it contract and it is big, then this suspensory ligaments relax or become slackened, and the lens is more round, or we called it a more convex. More convex. So convex, to remember it, when is it convex? Convex is when it is a C. Less convex is when it is lesser than a C. So convex, that's an easy way to remember it, is when it is C. So with this one, the ciliary muscle contract and the ligament relax. Okay, relax. Okay. So can you see nearby vision, CC, ciliary muscle contract, ligament relax. Far vision, ciliary muscle relax, ligament contract. And if you can remember this four letters and the order they must come, it is easy way to remember it. Now usually for level C and D questions, these questions are asked together with how do we rectify certain certain eye vision defects. How will we rectify long vision and far vision and near vision? But we will look at it just now. So it's important that we know this so that we can apply that knowledge to, I will show you a question on that one. The pupillary mechanism, remember the pupillary mechanism have to do with the amount of light that enters the eye. Okay, so it have to do with darkness and light, whether it's light or dark. Nee? Now what happens here is there are again two types of muscles here. The first type of muscles is the radial muscles. Now the radial muscles is the same as radius. So what is the radius of an eye? The radius of an eye is this from the middle there to there, from here to there is the radius. Nee? And the other is the circular muscles. So if you have a problem in remembering what it is, just look at it and remember those muscles are in circles. So it's the circular muscles, and the muscles that is from there to there is the radial muscles, the radial muscles. Now what happens in this one, that is if the radial muscle relax, so that one relax, so again it's like the rubber band, it's small, it relax, then the radial muscles is that ones, they are relaxed. So then the circulatory muscle contracts. The circulatory muscles contract and become smaller. Okay, and become smaller. So it's the opposite from the above one. So the ciliary muscle contracts, the radial muscles relax. So as they relax, they pushes this circle to get smaller. As they relax, they pushes the circle to get smaller. And lesser light can enter the eye. So this is a typical eye view for light, for viewing in daylight. This is for night. Okay, in the night, the pupil needs to be big so that light can enter the eye. So what happens here? Here the radial muscles contract, and the circulatory muscles relax. Okay, so can you see it works like that? And then more light is allowed. So the main thing to remember here is to what happens with the muscles. If these muscles relax, if these muscles become relaxed, they were tense, they were pulled far away, now they are relaxed, then the opening gets smaller. That means the ciliary muscles, have contracted. If the pupil is big, the radial muscles, these radial muscles have pulled it open, so they have contracted, and the ciliary muscle, the round ones, have become relaxed. Okay, they have become relaxed. So this is the way the two functions work here. Now, often in a question paper, we will see that they ask the question like this. They will ask the question, they will say, the diagram below shows the human eye under different conditions. Different conditions. Diagram A, diagram B, diagram 3, diagram 4. What is this one? This is day vision. What is this one? Night vision. How do I know it? The size of the pupil. The size of the pupil. What is this one? Far vision. What is this one? Near vision. How do I know it? Because this is more convex. Okay? So it's asked which two diagrams shows the results when the ciliary muscles contract. Now I must remember where is the ciliary muscles. Ciliary muscles is in one of these two diagrams. It's that muscle. This is the circulatory muscles and radial muscles. So ciliary must be here. And the circular muscles in the iris relax. So now they talk about the ciliary. They say the ciliary muscle contract. So where is the ciliary muscles contracted? it is there, né? The rubber band expand. So it's diagram 4. The ciliary muscles relaxed. Okay. Where is the ciliary muscles relaxed? Né? It's when the light is dim. So it's diagram 2. So what is the answer? The answer will be 4 and 2. So it's very important. Here, it's high cognitive, very difficult question, because they give you different processes in one question. And they ask you to work out which one contracts and which one relax. So it's very important that we understand this, and it's very beautifully summarized in Mind the Gap if you struggle with this one. Okay. Then I also say to you that often these questions is linked with graphs to make it higher cognitive. So here they say study the diagram below and answer the questions that follow. Okay. Now they say here, they say to us, A, what is A? Here, A is the iris, né? A is the iris. B is the retina, né? C is the yellow spot. Okay, so we must know that beforehand. Now they say graph and clarity of image on the retina. So from there, they give you this as a guidance to answer the following question. So this is high cognitive, né? This is a difficult question. This is typically what you can expect. Now they say, explain one way in which part B is suitable for its function. né? Explain one way in which it is suitable for its action. So what is part number B? Part number B is the choroid. Choroid. So how is it suitable? Because it have a lot of cones and rods, and which reduces reflection, and it's also very rich in nourishment to provide food for the body. Okay, so it's not a direct question. What is the function of B? It says to you, why is it suitable for its function? Because it's very glandular and rich. Then to explain how and why part A makes adjustment when the person moves from bright light into a darker light. Okay? So here they ask us, what will happen to the iris? When a person moves from bright light to a dark light. Okay? So now if they say to you this, they talk about light and dark, what must you explain? You must explain the pupillary mechanism. For the fact that I didn't say to you, discuss the pupillary mechanism, makes it a more difficult question. Which number 1 to 4 on the graph represents C in the diagram? Okay? Which number 1 to 4 represents C? So C, what is C? C is the yellow spot. Now they say, which number 1 to 4 on the graph represents C? So which number 1, 2, 3 or 4 represents C? Okay? What is my clue? My clue is reflective clarity of the image. So where is the image the brightest? The image is the brightest at number C. So where is the image the brightest here? At number 3. So number 3 will represent number C. Okay. Can you see? Difficult way of answering it, of asking it, but simple answer. Simple answer at the end of the day. C is where my yellow spot is. My yellow spot have the greatest amount of cones, so this is the best clear place for focusing, for focusing. So if the light comes in here and it bends, it should focus on there to make sure that we have a clear image. Now they say, give a reason for your answer. Very high cognitive, difficult question. Give a reason for your answer. Now you must say, because C is the retina and it contains the most cones which make the clearest image. That is why point 3 on the graph is that. So you have to explain your answer. Name the part of B. Name the part of B, which correspond to number 2 on the graph. Okay, so number 2 on the graph. Where will I find that? Okay, number 2, there's no clarity. No clarity. Where will I find no clarity? Where can I see nothing? I found it here, and what do I call that part? I call that part the blind spot. Okay. So typically this is how examiners tweak questions on the eye. They ask you the function, but you have to get the question or the answer from looking at 2 diagrams to get the answer. Okay. Another question that is higher cognitive around the eye is this one, where it says to you, the diagram shows 2 eyes, X and Y. Okay, just make this a little bit smaller. The diagram shows 2 eyes, X and Y, that focus on objects, represented by arrows. So this eye, okay, can either focus on that one or this one, and this eye on this one or this one. Okay. Objects A and C were 2 meters away from the eye. Object B and D were 7 meters away from the eye. Okay. So immediately here, you must start making your deductions. And the moment you must analyze, evaluate, and come up with the answer. What do I know? I know my content. I start with my content. What do I know? I know this is convex. So I know this is for nearby vision. Okay, so I know this is for nearby vision. Okay, and that one will then be for far sight. Okay, for far sight. So the moment you can work that out, you will be able to answer the question. Write down the letter only of the object X, IX, so IX is focused on. So IX is focused on B because it is for foresight. IY is focused on, IY is focused on C because it is near vision. So can you see, without mentioning any muscles, any ciliary muscles, the lens, by only giving you the 2 diagrams, you must come up with the answer which is higher cognitive. Name and describe the process that allow Y to form a clear image. So they ask you near vision. Okay. So in near vision, the ciliary muscles contracts, the rubber band gets bigger, ciliary contracts, and the lens relax or become more convex and more light rays is bended. Okay. So can you see the application? So what they are asking you is they are asking you to describe accommodation to nearby objects. The next part we've done the eye, we've done the ear. The next part which we must do here is the brain. Okay. Now the brain is usually, let's see where's my my brain. Okay. The next part that we must do is the brain. Now, usually what the examiners ask about the brain is they again ask the different parts and the different functions. But now they tweak it a little. They won't say to you, the cerebellum controls all voluntary movement, controls muscle to maintain balance. Nee? They will tweak it by giving you an example. Nee? The cerebrum contains all voluntary actions, nee? And receives and interprets sensations from in there. But in the cerebellum, okay, the cerebellum, how do I remember which one is which one? I always say that this one looks like in a bell. In a bell, there's that little thing that hangs there that makes the sound. Okay, that makes the sound, and that is the cerebellum. Okay, the cerebellum, and it coordinates all voluntary. So the moment the bell rings, I run. Nee? I run, so that is how I link it to remember cerebellum. Okay, cerebellum, but it also maintains balance, nee? Which is non-voluntarily. Nee? So this muscles which contract is non-voluntarily, while that one is voluntary. So please make sure that you know the different parts of the brain. It's a direct recall questions that is asked in there. Then the syllabus also say that we must know the 3 types of neurons. We must know a sensory neuron, nee, that take it to the senses, nee, to the senses. We must know the motor neuron. The sensory neuron pick up the senses, the stimulus, and take it to the brain, and the motor neuron take it from the brain back and through. Often, as part of the question papers, in a few question papers that we looked through, we saw that they are often very eager to ask you to make a diagram of a neuron. So make sure as your level A questions, your knowledge that you know that one. Now the way that they link the different type of neurons, in the reflex action. So we can always expect that there will be a question on the reflex action. That is a given. Okay. So what do they ask? So firstly, I must know which neuron will be this one, that takes it from the stimulus, there's the stimulus, to the central nervous system. And that will be my sensory organ, or sensory neuron. In the back, there is the interneuron, and from there, the one that takes it to the muscle is the motor neuron. Okay? So that's easy to remember. The next thing is sometimes we need the action so quickly that, for instance, if we're getting hurt or something, we need an action to protect ourselves. And that actions, we call it the reflex arc. That is where the action does not actually go to the brain. It still goes to the central nervous system, which is the vertebral column, which is inside the vertebral column, but it does not go directly to the brain. Okay. So let's look at some questions to see where my higher cognitive questions come in here. Okay, they say here, study the reflex arc below. What is a reflex action? Easy, you should have learned that. Label the following: the functional connection at D. Okay, the functional connection at D. Okay? So what does that parts connect? It is the synapse. Synapse. And then they say also neuron B. What is neuron B? It's the interneuron. Okay, easy. You should have actually be able to do it all. Now they say, state the significance of the functional connection at D. State the significance. They ask you first, they ask you the name. That is, it's the synapse. Ne? That's easy. But now they ask you, why? Why is it built like it is built? This is higher cognitive. Ne? This is a difficult question. Ne? So why does it ends most like this? Ne? And then the next neuron starts like that. Why is it not one structure? Why is it like this? Ne? And then, so this is why you must think at what the answer will be. So the answer will be something like, it ensures that the impulse move in one direction only. Okay? And it prevents the continuous stimulation of the neurons. You know what happens if you continue stimulating something, ne? You continue stimulating, at the end it have no effect anymore. So it's very important that our neurons are not stimulated all the time. And it ensures that it is transmitted from the sensory neuron to the motor neuron. That is actually the same answer as the first one, in the correct direction. Okay? Because it is at the end of the axons here and at the beginning of the dendrites there. Okay? Write down in correct order the letters only of the neurons involved. Nee? From the time a stimulus is received until a response takes place. So there is the stimulus that is received. So what is the first one? A. Then it goes to B, and then it goes to C. Okay, little bit more easy question. Then this is also a higher cognitive question, a question that only that requires more thinking. Ne? Explain the consequences for a reflex action if neuron C, if neuron C were cut or damaged. Now they ask you what and why. Eh? What and why. That is consequences. So this is more difficult. Eh? Explain the consequences. So you will start by saying neuron C is the motor neuron which takes the impulse from the central nervous system to the reflector or to the muscle. Eh? So if it's damaged, it means that there will be no reaction. I will find the stimulus, I will feel the stimulus, I will feel the needle in my finger, I will feel the heat under my foot if I step on a coal, but I will show no reaction because the motor neuron is damaged. If they have changed it, if they say to it, if neuron A is damaged, if neuron A is damaged, what will happen? Then you say neuron A is the neuron that takes the stimulus from the stimulant to the central nervous system. So if it's, let's say, damaged there, what will happen? I won't get any stimulus. I can step on a hot coal, but I won't feel it, so I even pull away my leg. Okay? So that is the application in there. And in this one, we often find, draw a label diagram to represent the structure of neuron A. Okay? So you should have drawn a nicely neuron in there. Okay? Let's look at another question. Okay, it's actually I want to show you, this was in 2014 and this was in 2015. Okay, so you can see more or less same type of question. So label each of the following regions. Region D, region E, content, write down the letter content, explain the action explain the effect on the reflex action if part B was damaged, higher cognitive. A nerve pathway is above, response is above about 1.5 meters in length. A nerve impulse travels at 75 million per second. Okay, this is an ordinary calculation. Explain the significance of a reflex action. So the significance is, why is it necessary? Why is it necessary? It is to protect the body by reacting quickly. Okay, so that is the significance of it. Okay. Then this one, let's just quickly look at this question before we end the session. Describe how different parts of the ear and brain allow for hearing. Okay, just to show you that hearing was asked as a level A question, direct recall question. Then another type of question that they actually like to ask is sometimes or many times they will link the eye or the ear with an investigation. This one is on reaction time. So this have to do with your reflexes, your reflex time. So you can even expect questions like this. A learner carried out an investigation to measure the reaction time of two people, A and B. Each person had to ring a bell when a light is flashed on. The time taken for every person was reacted and recorded and plotted in the bar graph below. Okay, so let's quickly look at the bar graph without even looking at the questions. What must I first see in this bar? I must see that the reaction time was long and that it have become lesser over time, but then it starts doing this. Okay, so that's my first deduction. My first deduction is that as many times, the more they practice it, the better their reflexes are. The second one is that person B is every time slower. Was in the beginning slower than person A, but at one stage he become quicker and then slowly he becomes slower again. So that is my second deduction that I can make. What was the slowest reaction time? Okay, so the slowest reaction time will be the one of that one. They don't say to you of person A or B, so you look generally at that one. And this is here often where we want to read more into a question that is there. You just answer the question. Describe how the reaction time of person B changed over the 10 attempts. So you will say it decreased, but at one stage it was more or less the same. It decreased, and then it started going to up. So this will be the graph for person B. Okay, for person B. While this will be the graph for person C. It have gone quicker, but it have gone up and then there. So that will be the two trends of the graph. Describing trends in a graph, more difficult questions, this is what you can expect. What was the stimulus in this investigation? The stimulus was the light impulse. When I see the light impulse. So it was not a flashlight. What was the stimulus? The stimulus was the light impulse that I saw. How would the reaction time of person A have been different if he or she have been under the influence of drugs? Nice high cognitive question. It would have slowered the investigation. It would have been slowered. Okay. So that concludes our session on the nervous coordination. Thank you.